In this video, we will talk about polynomials and problems based on polynomials. Expressions of the type x plus 2, y square plus 4y plus 6, half z cube plus root 5z minus root 6, etc. are polynomials in x, y, and z respectively. Polynomials are denoted as Px equals x plus 2 because this is a polynomial in variable x. Py equals y square plus 4y plus 6 because this is a polynomial in variable y. Pz equals half z cube plus root 5z minus root 6 because this is a polynomial in variable z. Let us understand peculiarities of polynomials. In the polynomial Px equals x plus 2, the maximum power of x is 1, see here, which is also the degree of the polynomial, which is 1. Therefore, x plus 2 is called a linear polynomial. Py equals y square plus 4y plus 6. In this polynomial, the maximum power of y is 2, which is also the degree of this polynomial. Therefore, y square plus 4y plus 6 is called a quadratic polynomial. Pz equals half z cube plus root 5z minus root 6. In this polynomial, the maximum power of z is 3, which is also the degree of this polynomial. Hence, half z cube plus root 5z minus root 6 is called a cubic polynomial. The power of each term in the polynomial is whole number 0, 1, 2, 3. We can observe that the power of the variable x here is 1, in here it is 2, and in this polynomial it is 3, which are whole numbers. So the requirement for an expression to be a polynomial is that the power of the variable must be a whole number 0, 1, 2, 3, so on and so forth. Their coefficients, which are the numbers attached to the variables, in this case 1, 4, root 5, root 6, etc. can be any real numbers. Now let's understand which expressions are not polynomials. 2 upon x plus 3 is not a polynomial because the power of x here is minus 1. Here it is 1 upon x whose power will be minus 1. So this expression is not a polynomial. Root x plus 4 is not a polynomial because here the power of variable x is half, which is not a whole number. 4x raised to 1 upon 3 minus 5x plus 3 is not a polynomial because the power of variable x here is 1 upon 3, which is not a whole number. Plain real numbers such as 3, minus 3 by 2, root 5, 7 by 5, can be called as polynomials because each one of them can be written in the polynomial form as 3 can be written as 3x raised to 0. Here, degree of this polynomial is 0. Minus 3 upon 2 can be written as minus 3 upon 2 x raised to 0. Here also the degree is 0. Root 5 can be written as root 5 x raised to 0. The degree is 0 here. And finally 7 by 5 can be written as 7 by 5 x raised to 0. Here the degree is 0. Now we will understand what is value of polynomials. Consider a polynomial px equals x square plus 4x plus 6. If we replace x by 2, we will get p of 2 equals 2 squared, replacing this x by 2, plus 4 multiplied by 2, replacing this x by 2 plus 6, which will be 4 plus 8 plus 6. That is, p of 2 will be 18. We say that the value of the polynomial at x equals 2 is 18. Now we will understand what is zero of polynomials. Consider a polynomial px equals x square minus 4x plus 4. If we replace x by 2, we will get p2 equals 2 square, replacing x by 2, minus 4 multiplied by 2, replacing this x by 2, plus 4. It will be 4 minus 8 plus 4. So p of 2 will be 0. Here, value of px equals x square minus 4x plus 4 at x equals 2 is 0 because p of 2 is 0. Hence, the 0 of this polynomial is 2. So, the value of the variable x for which the value of the polynomial becomes 0 is known as 0 of the polynomial. Consider a quadratic polynomial py equals 4y cubed minus 3y squared minus 6y plus 32. If we replace y by minus 2, we will get p of minus 2, replacing this y by minus 2, this y by minus 2, this y by minus 2, and this y by minus 2. Minus 2 cubed will be minus 8, minus 2 squared will be 4. So we get minus 32, minus 12, plus 12, plus 32. Minus 12 plus 12 will be 0, minus 32 plus 32 will be 0. So p of minus 2 will be 0. Here, value of py equals 4y cubed minus 3y squared minus 6y plus 32 at y equals minus 2 is 0. Hence, 0 of this polynomial is minus 2. Now the question is how to find 0 of a polynomial. Suppose we want to find 0 of the polynomial px equals 3x plus 5, which is a linear polynomial. We will start by assuming px equals 0, so that 3x plus 5 will be 0. which gives us 3x equals minus 5, x equals minus 5 by 3, which is the zero of the polynomial px equals 3x plus 5, because p of minus 5 by 3, after replacing this x by x equals minus 5 by 3, we get 3 times minus 5 by 3, replacing this x by minus 5 by 3 plus 5. This 3 cancels with this 3, minus 5 plus 5 is 0. Geometric meaning of zero of a polynomial. Consider the graph of a linear polynomial px equals 2x minus 4. This is the graph of the polynomial 2x minus 4. Let px equals 0 so that 2x minus 4 will be 0, 2x will be 4 and x will be 2, which is the zero of px equals 2x minus 4. And also x equals 2 is the x coordinate of the point where the graph of the polynomial, which is this, intersects the x-axis. So the graph of this polynomial intersects the x-axis in the point 2, 0. Here 2 is the x coordinate, which is the zero of px equals 2x minus 4. In short, geometrically speaking, zero of a polynomial is the x coordinate of the point, the x coordinate of this point, where the graph of the polynomial, this is the graph of the polynomial, intersects the x-axis. So this graph intersects the x-axis in 2, 0, where 2 is the x-coordinate of this point, which is the zero of this polynomial. Consider the graph of a quadratic polynomial px equals x square minus 4x plus 3. So this is the graph of polynomial px equals x square minus 4x plus 3. Let px equals 0 so that x square minus 4x plus 3 will be equal to 0. Factorizing this quadratic polynomial, we write x minus 1 multiplied by x minus 3 equals 0. That gives us x equals 1 from this factor and x equals 3 from this factor. These are the two zeros of the quadratic polynomial px equals x square minus 4x plus 3. Also, x equals 1 and x equals 3 are the x coordinates of the points where the graph of the polynomial intersects the x-axis at this point and at this point. Geometrically speaking, zeros of px equals x square minus 4x plus 3 are the x coordinates of the points where the graph of the polynomial intersects the x-axis The graph of this polynomial intersects the x-axis in points 1, 0 and 3, 0, and the x-coordinates of this point, that is 1 and 3, are the zeros of this polynomial. So this is about introductory part of polynomials, geometrical meaning of zeros of a polynomial. In the next video, we will understand relationship between zeros and coefficients of a polynomial. If you like this video, please click like button, subscribe this channel, share this video with your friends and relatives. Thanks for watching. Keep watching Number Collage.